Okay, today is called Complex Numbers, Day 1. And complex numbers are different than normal numbers, of course. That's why you're going to learn about them. And mostly it revolves around I. And I am a little disgusted about the 1 million ants for every person in the world. That's a lot of ants. All right, I'd like to just thinking about that for a second. If there are 7 billion approximately people in the world, if there's about 7 billion, 7.1 or whatever, uh, and you add 1 million ants for every human, so you can take 7 billion and multiply by 1 million. So that takes 7 billion and adds 6 zeros to it. Do you know what we're at then? What's the first notch after billion? Trillion. And what's after that? Quadrillion. That's right. In case you've never gone that far before. After billion comes quadrillion. So that would mean there are around 7 quadrillion ants in the world. All right, using prior knowledge, how could you graph this equation? So basically, give me some stuff that you know about this equation. Anybody can think of anything smart? I'd be happy to take your thoughts. I can see one thing right away. I know something about this graph right away. What do you know? It's a parabola. Good. There's more. Yes, ma'am. It's going to have a minimum as in a low spot, so it's going to look kind of like this, except probably not exactly that. In fact, I know it's not exactly that. What do you think, sir? Y-intercept has to be 6, because the y-intercept is where x is 0, and so those would make me say that, yeah, it's 6. All right, I agree. So now I can move this thing over and say maybe it's something like that. More? How could you find its x-intercepts? Yes, sir? Yes, quadratic formula or factoring. And the first thought should always be, can I factor it? Because if I could set this equal to 0 and factor it, you'd be able to find the roots really easy. And if it doesn't factor, and that's the ZPP, by the way, zero product property, you're multiplying two things together and equaling 0, then if it doesn't do that, then you got to use quadratic formula. So would you try to factor it quick? Because all we know for right now is that it goes through that spot. That's the only spot we know of for sure. We know it's a U shape. It's got a low spot, a minimum. We don't know the roots, so it'd be pretty handy if we did. Does it factor? Okay, I agree it doesn't factor. So then it's quadratic formula. X equals negative b, negative 2, plus or minus the square root of b squared, which is 4, minus 4ac all over 2a. And a was 1 and c was 6. So that's negative 2 plus or minus the square root of, whoa, wait a minute, 4 minus 24? That's negative 20? That's the kind of thing we're going to do to you today. If you have a negative underneath the square root, you normally just say, well, there's no answers, there's no roots. All that means then is that I know this thing does this. It doesn't touch. You know what I mean? It doesn't. You can't touch this line right here, otherwise it would have roots. So this does not tell me where the roots are, because if they're imaginary roots are kind of like leprechauns. I know this thing has roots. I know that they're there, but I can't see them. So yes, I believe in leprechauns. Okay, anyway. If I were to need the vertex, can you think of some other thing that we got tested on not too long ago that would tell you what the vertex was? Complete the square. The vertex CTS, complete the square. All right, so if I were you right now, I'd practice the complete the square deal. See if you can find me where the vertex is. Actually, I'm going to leave that back in there. In case you forgot that process, you just move the 6 over, and then you do half and square. Remember this? Mac, would you walk me through half and square on this deal? Got it. Move the 6 over. Now what? Half of the 2, yep, which is 1. And then square it. Makes plus 1. Good. So 1 squared is 1. So we got plus 1 and a minus 1. Yes. What did you get for that part right there? That part factored, right? Yep. And then this part at the end? Plus 5. That tells me the vertex. The vertex is at -1, 5. So now I know that it doesn't quite look the way I thought it looked. I mean, I know generally it was right, but -1, 5 is the low spot's right there. So then my parabola goes like that. That's a good review. Covers lots of stuff we've done lately. Quadratic formula. It even showed us this quadratic formula that had a negative underneath the root. And the thing is, all you really have to know for today is that is a complex number, and we need to know how to handle it when we get a square root that has a negative. In the past, we allowed you to just say, doesn't have real answers. Now, we want to know what are the imaginary answers. So, that really boils down to this. If I could simplify that part, the rest of this will be easy, right? So then it's the square root of -20. Do you agree that I could break that into the square root of 4 times the square root of 5, but then I haven't addressed the whole negative thing? Get what I mean? So then the square root of -1 would finish it off, right? Now if I multiply this times this times this, I would get -20. Well, mathematicians did it exactly that way, and then they just decided to name the square root of -1 I. So this is square root of 4, which is 2. This is square root of 5, which I can't simplify anymore. So do you remember what that's called? It's not called imaginary. What's the square root of 5 called? It doesn't come out nice. It is a radical, yes, but it's a certain kind of number. Irrational. Yep, it's irrational. As opposed to imaginary, which is what this was. This was imaginary. That's irrational. Okay, so 2 times the square root of 5, and then there's an I. That part right there, that's an I. Now, normally we don't put the I at the end, because the end, it looks like the I is underneath the square root, and that would be totally wrong. You don't want your square root to have the I in it. The square root is outside of the I. It is usually put right there. 2I root 5. Now, this is -2 plus and minus 2I root 5 all over 2. All I did is replace this with that. Now do you get the 2's will cancel? Don't worry about the I being there. It doesn't cause any problems. 2 goes in here once, 2 goes in here once, and 2 goes in here once. And dividing by 1 doesn't really do anything, so we just cancel that off. And we get -1 plus or minus I root 5. If you wanted to say 1I, you could. There's your 2 answers. Notice it's 2 answers because of the plus and minus. By the way, this is an important thing about imaginary numbers like this. They always have 2. There's never just one imaginary. If there's going to be an imaginary answer, there's going to be at least 2 of them. Could there be more than 2 of them? I think there can. I can't think of how right this second, but your answers today there'll be no more than 2 imaginaries. But again, you'll never have one imaginary, because think about it. There's a plus and minus in the formula, isn't there? And if there's an imaginary number, that means that there was a negative underneath the square root. And the only way for this plus minus to go away is if this whole thing was a 0. And it's not going to be a 0 if it's an imaginary. Logically, then, it has to be a plus and minus in front of all your answers, and therefore, there has to be 2 answers whenever there's imaginaries. Okay, so let's move on to the next thing. Everybody take a look at this. Oh, wait, talked about that answer already. Leonard Euler's the one who gets the credit for imaginary numbers. He figured out a way to do it. He introduced the symbol I to represent square root of -1, and apparently, I did talk to an engineer who dealt with electricity, and he says we use it a lot when we're doing complicated equations involving electricity. So it actually gets used by engineers to solve complicated problems. Frankly, they're probably so complicated that I couldn't even explain it anyways, even if I understood it. So I'm just saying it's not something you'll be using in your everyday life, everybody, but there are people who do, who actually use this regularly in their job. All right, now let's talk about some weird things that happen with I when you like start multiplying i's together. Remember, i's square root of negative 1. So I to the first power is the square root of negative 1 to the first power, which is the square root of negative 1. Make sense? Okay. This I squared means square root of negative 1 and squared, which means times itself, right? Did you ever notice that if you take two square roots, like square root of 3 times the square root of 3, that the answer comes out to whatever's underneath the root? The square root of 3 times the square root of 3 makes the square root of 9, which is 3. And the square root of 5 times the square root of 5 would be the, oops, 5 would be the square root of 25, which is 5. Notice it's the thing underneath the root. Take a wild guess what the square root of 8.3 times the square root of 8.3 is. 8.3. Getting the pattern here? So, given that, what's the square root of negative 1 times the square root of negative 1? Negative 1. And therefore, if I squared is negative 1, that is a really powerful thing on the ACT tests. They ask you this in different ways. They'll a lot of times say, okay, well, you got 5i squared. And they're trying to test to see if you know that that really means 5 times negative 1, which really means negative 5. Okay, so if you know that this is really negative 5, the rest of the problem is really pretty easy. As long as you understand that I squared is negative 1. All right, going past that, though, it gets even weirder. But this one's the most important of all of them, no doubt. Of all of these things, the reason we're really talking about this is because I squared. Because I squared being negative 1 is really handy in complex number problems. But I to the third is an interesting point then. Do you get I to the third is really I squared times I? Think about that. I to the third would be I squared times I, right? And what's I squared? So therefore, what's the answer? If this is negative 1, what's the answer? Negative 1 times I, which is negative 1 times I, which is negative I. So I cubed is equal to negative I. I to the fourth, would you agree that's really 2i squareds? Not 2, but I mean like I squared times I squared. So is that really then? 1, because it'd be negative 1 times negative 1, which makes 1. So it's really a strange thing when you square I, you get, or sorry, when you just have I to the first, you get negative 1. Then when you square it, you get negative 1 without the square root. Then when you cube it, you get negative I. Then when you put it to the fourth, you get plain old 1. It's different every time. But now it's going to start cycling back, I think. Because would you agree I to the fifth is the same as I to the fourth times I? And what's I to the fourth? 1. So it's really 1 times I, which is really... So I to the fifth is actually equal to itself. Isn't that weird? Take something, put it to the fifth power, and you get the same thing back again that you had in the first place. It's nothing else like that except for maybe 1, because you put 1 to the fifth and you get 1. But the weird part is this is other things up until then. It's different, it's different, it's different. When I get back to here, I to the fifth is actually back to I again. All right, so that's just some weird things. Remember, if you're doing a problem like this, just break it into a couple things like I to the sixth. I could say that's of course, I times I times I times I times I times I. Or I could say I to the fourth times I to the second. And if I know what they both are, it's easy, right? So what's I to the fourth? 1 times I to the second. Negative 1. What's 1 times negative 1? Negative 1. All right. So we'll have a few questions like this for you. If you'll just want to look at the pattern part of it, I, negative 1, negative I, 1. I, negative 1, negative I, and take a wild guess what the next one would be. You getting the pattern? These four numbers get repeated over and over and over again. So what's I to the eighth? It's the next one in the pattern. The fourth one in the pattern is a 1. There we go. And there's the pattern again. And it would keep going like that, over and over and over. That's just a weird thing that I does. Okay, so here's some really easy ones. If you had to say what's the square root of negative 7, you can't just say no real solutions. You have to tell me what the imaginary solutions are. And so it's really simple. You break it up into root 7 and root negative 1. Except you should know what negative 1 is. Negative 1 is I, so then it's I root 7. Try the next one. Square root of 4. Square root of negative 4. So hope you said it was the square root of 4 times the square root of negative 1, which would be 2 times, what's the square root of negative 1 again? How many had 2i as your answer? Good. Okay, square root of 24. You should be getting to be quicker and easier for you every time. Root 6, root 4, and then root negative 1. So some of those actually simplify a little bit. Turn your answer and show me if you've got this one. Zoom in on it nice and tight so I can see it. Yes, yes, yes. You did your square root of 4 wrong. Yes, 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 yes. You can change your, yeah, make a few little tweaks there. Square root of 4 was the one you were doing. Okay, good, 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 good. Put the I second, not first. Good, good, good. Yep. Okay. So this one is 2. This one is the square root of 6. This one is I. So then it's 2i root 6. All right. Now this, all we're doing is throwing a 7 plus in front of the problem. So the answer is 7 plus whatever comes out. Okay, so what is the square root of 50? Don't know it in my head, but I could break it up. Root 25, root 2, and root negative 1. Don't forget that one. 5i root 2. And there is your answer. Now, this is one of those little picky things about math. You know how we in this country put our question marks at the end of the sentence? And in Spanish, they put the question mark at the beginning of the sentence. How many of you guys were aware of that? Okay, so it's kind of a cool, I think it's a cool system because then you know ahead of time how to say it. Instead of, if you're reading a sentence and it turns out it's a question at the end, you tend to like go, you know, try to tweak it at the end to make it sound like a question. Anyway, my point is that this, math-wise, there's a right way and a wrong way to write this. And this is the right way. A lot of people fall into this little trap. They'll do a problem that was more complicated than this one, and then they'll write the answer like this. 5i root 2 plus 7. And technically that is wrong. It's not that big of a deal, but the imaginary part is supposed to be last, and the real part of your answer is supposed to be first. Okay, so if there's two terms, you should rearrange them like this so that the real part first and imaginary part second. All right, so this one's already set up right with the real part first. Go ahead and finish that off and write out your answer. Real part first. Simplify it. Your answer's probably like, 2 minus 6 root 2 or whatever it is with an I in there maybe. Show it to me. I'll tell you if you're right or not. Yes, 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 yes. Need an I in there and you'll have it. Yes. Something's wrong with question?
No, negative.
Oh, my bad. Ouch. Yeah, there's no negative in the square root. I told a lot of people they were right, and I totally missed it myself. This one's just a plain square root of 20, so it's root 4 and root 5. So it's 2 minus 2 root 5, and that's it. There's no I. My bad. Okay. It's easy to get trapped in that, isn't it? Because you've been doing negatives every one until now. All right, here's another one with no negative underneath the square root, so I guess it's more normal. But don't leave it as a plus minus. Oh, how many people got that problem wrong on the test? Square root of 36 is 6. So the answer is not 11 plus and minus 6. That's a math problem. That's 11 plus 6 and 11 minus 6. Those are the two answers. If you left it this way, it's not got the answer yet. The answer would be 11 plus 6 is 17, and 11 minus 6 would be 5. So 17 and 5 are the two answers. Notice there's no I involved because there's no negative underneath the square root. Okay. Any questions? I've covered a lot of stuff. I think you're going to be fine when we get to the harder ones here. Everybody try this first one. Remember, there's a little simplifying involved after you get that I worked out. Your answer will simplify because that has an even number in it. So then 2 and 6 and whatever this comes out to be can all simplify down. Show it to me. I'll tell you if you're right or not. Yes. Forgot the minus. Plus and minus. Yes. Oh, wait, you got a square root still. The square root's gone. Yes. 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 The 1 doesn't disappear. The 1's still there. When you cancel it, don't forget that there's still a 1 there holding its place. Yes. 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 Okay. So that one, for those at home, I was saying yes to this. If kids simplified that and said 4i, that's a good start. Then 2 goes in here once, 2 goes in here, and notice it doesn't disappear. There's a 1 there. 2 goes in here twice, 2 goes in there 3 times, 1 plus and minus 2i over 3. 1 plus and minus 2i all over 3. All right, I think that's enough practice on that. You got homework, which is right there. Complex numbers, worksheet A. Let's see if I can pull it up quick here. All right, first part should be easy peasy. We just practiced a bunch like that. Let's move down to problem 2. Part A, solve the following problems by factoring or using the quadratic formula. Now when the discriminant comes out negative, you won't say real solutions. You'll give the answer using complex numbers. So again, most of these are going to have like plus and minus the square root of -6 or something. So you'll just have to have your answer have an I in it like the ones we were just doing. So this one, if it factored, cool, but this one doesn't. I'm pretty sure. Let me think. 15 is 3 and 5. Well, 3 and a 5 can make it 2. There's a chance this one factors. X and X. And then what if I did plus 5 and minus 3? Does that factor? Is that right? Can anybody verify if that multiplies out right? Seems like people are saying it does. Okay. So then this is it. This is factored. And the cool part is then I can use a zero product property to tell me my answers. My answers are x equals -5 and x equals 3. I'm done. That's it. Wasn't any complex numbers here. It's just simple, real answers. -5 and 3. Okay, this next one, I bet you anything won't factor. It doesn't. So then I got to go x equals -b plus or minus square root b squared minus 4ac, 4 times 1 times 13 all over 2a, all over 2. This part right here makes a negative number underneath the square root. That's where you'll have your I come in. So then I'll have -6 plus and minus. I'm not going to give you the right answer here, but let's say it's 7i all over 2. It's probably more like 8i. It's not, but something even. So then this, and this can cancel, and remember, there'll be an I in your answer. Your I won't ever cancel in the quadratic formula. Okay, I didn't want to give that answer, so I purposely did it wrong with an 8 there. See if you can find it yourself. I don't want you using calculators on this, though, just because the test will not allow calculators. So we have a test coming this Friday, and the test is on this stuff. We're going to teach you for 3 days. However, you do view day Thursday, test is on Friday, and so don't get used to calcs. I know 4 times 13 is a little bit of a pain, but you can handle it. 13 times 4. Okay, that's all I got for the video for today.